Today we are going to be introducing the concept of slope on the coordinate plane. Now when we have a line running on the coordinate plane, the slope is the determination of one specific aspect of that line. Its orientation or direction, which way it's facing. It does not matter where the line is on the graph. The location is irrelevant. So for that reason, lines that are parallel to each other, regardless of their location, are going to share the same slope value. So if you take a look at this diagram, you'll see how the slopes shake out compared to each other. In the middle, we have a horizontal line parallel to the x-axis. That has a slope value of 0. Think of it as the center of the slope spectrum. From there, ranging upwards, we have positive slopes, and ranging downwards, we have negative slopes. So if you are reading a graph from left to right, a line that climbs has a positive slope. So if we're reading this blue line from left to right, you'll notice that we're going upwards as we go left to right. That's a positive slope. The green line is going up even faster or steeper. That is a greater slope value than the blue line. So you could pretend that this is a slope value of 2 and this is a slope value of 3. A negative slope means that the line is tilting downwards. You will see a negative number for the slope value. You cannot have a downward tilting slope without that negative number. And you can't have a negative number without that negative slope, that tilting downwards. So if I'm going from left to right, then it's going downwards. The purple line is going downwards even faster. That is a bigger negative number. It's technically less than, but you get the picture that this could be -1, this could be -2. So how do we find the slope value on a graph? Well, the first thing is to understand the formula. And the formula is remarkably simple. The slope is measured as the change in the y value over or divided by the change in the x value. So if we can determine how far the y value has changed and how far the x value has changed between any two given points, then we have our slope. That's all there is to it. So step 1 is to find any two measurable points on the line. Measurable being the operative word. So if I am looking at this blue line here, notice that I've already put the measurable points on it, but they have a specific thing in common. They are on spots where my blue line is crossing both coordinate lines, a vertical line and a horizontal line. Think of it like railroad tracks crossing right through an intersection of streets. If you don't have it right at that intersection, then you will not be able to accurately measure one or other, or possibly both, of the dimensions. So if I chose this spot right here, that would not work, because while I can measure the x value because it's on a vertical line, I cannot accurately measure the y value because it is in between horizontal lines. So measurable points have to be at those T intersections. Once you have your two measurable points, then the rest is just counting. First is to count the change in height, aka the change in y value, from the first point to the second point. My first point is always the point that's further left. My second point is always further right. Technically, it doesn't matter. Just make sure that you are starting at the same point each time. So if I am calculating from here, I can see that from my first point to my second point, it is up 1, going up 1. Then I count the change in the x value from the first point to the second point. So if I'm seeing how far forward it goes, I can see that it is +2. Therefore, I put these two numbers together into my ratio, the change in y on top So my change in y is 1, and my change in x is 2. So my slope for the blue line is 1/2. We can try it with the pink line over here. Once again, going from the first dot to the second dot, we see that the vertical change is down 1. That means that it's -1. Down means minus, negative. And then we are going forward 1, 2, 3, 4, which means that we have a slope of -1/4, -1/4. For our green line, we count 1, 2, 3, 4, 5 up. So 5 is our y value. And 1, 2 forward, we've got 2 as our change in x. For the orange line, we're going 1, 2, 3, 4 down. So that's -4. And we're only going forward 1. So that's -4/1, which just equals -4 for short. And then finally down at the bottom, we've got the brown line. The brown line, well, if we tried to make a fraction out of it, we can see it doesn't go up or down. So it's got a fraction of 0/1, 2, 3, 4. 0/4. But as we know, any fraction with a top number of 0 is just going to equal 0. So our slope is 0 for the brown line, the horizontal line. Now, you may not be given a graph to look at. You may just be given coordinate pairs. In that case, you're just doing simple math between the x values of the two pairs and the y values of the two pairs. Our general formula is still the change in y over the change in x, but if you want, you can break it down into the second y value minus the first y value to get the change in y, and the second x value minus the first x value to get the change in x. Now, me personally, I don't really like creating this subtraction, especially when we've got negative numbers involved. I hate subtracting negative numbers and having to figure all that out. Instead, I usually like to just find the change in x and the change in y just by counting from one value to the other and seeing how far forward or backward or up or down I have to go in order to get from the first one to the second one. Once again, as long as you are starting with the same point each time, it really won't matter which way you go, subtraction or addition. Let me show you. If I'm starting with my x values go from 3 to 5. 3, 4, 5. 2 plus 2. My y value, on the other hand, is going from -4 to +1. That's, once again, going forward. So I can just count starting at -4. I'll go -3, -2, -1, 0, 1, 5. So it took me +5 to get there. And so if I put those together, I end up with a slope of 5/2. For the bottom one, if I start with the x value again, I'm going from -5 to 0, -4, -3, -2, -1, 0. That's +5. And then from 5 to -4, I'm going to count down. 4, 3, 2, 1, 0. -1, -2, -3, -4. 9. I went down 9 in order to get from 5 to -4. So I end up with -9/5 for my slope. All right, it's practice time. And this is going to start with a flash practice of simply positive or negative slope. What I'd like you to do is to determine in 5 seconds or less whether the slope of each of these lines is positive, negative, or 0? Go ahead. Number 1, positive, negative, or 0. This is a positive slope. Get used to seeing that climb. Number 2, or B, negative slope, going downwards left to right. Number 3, another negative slope, going downwards left to right. Number 4, D, that is just a straight horizontal line. That is a 0 slope. E, going upwards pretty steeply. This is a positive slope. Pink, a little less steep, but still going upwards as it goes left to right. That's positive. G is a negative slope. And finally, H is also a negative slope. So with that established, let's find the slope value for each of them. Feel free to pause the video if you want to give it a good long try, but I'm going to get right into it. So here we have blue. We are going up 2. We are going forward 2. We end up with 2 over 2, which simplifies to a slope of 1. This is one of our benchmark slopes, the slope of 1. Number 2, we are going down 3 and we are going forward 3. So negative 3 for the y, positive 3 for the x, negative 3 over 3 simplifies to negative 1. Another benchmark slope. This is what the negative 1 slope looks like. C, we're going down 1, so that's negative 1 for the y, and we're going forward 2, that's positive 2. We have negative 1/2 for this slope. The orange one, we already determined that the slope is 0. So I won't even speak more about that. E, we've got going up 3, so we've got positive 3, and we're going forward 1, so we end up with 3 over 1, which simplifies into a slope of 3. Pink, we have 1, 2, 3 up, and 1, 2, 3, 4 forward, so we end up with a slope of 3 over 4. G, we are going 1 down and we are going 2 forward. So we end up with a slope of negative 1/2, which is the same as the slope for C. And you can tell that these are parallel to each other. They have the same slope. They have that same orientation. And finally, the last one, H. We have 1, 2, 3, 4, 5 down, so minus 5 for the change in y, and 1, 2 for the change in x. So we end up with negative 5 over 2 for our slope.